Hello, everybody. Welcome to another episode of AdvaTech podcast. Today, I'm joined by a very special guest, Dr. Amin Abbasi. Amin is a business development manager at imec in Belgium. Amin, thank you so much for joining me. Could you please go ahead and introduce yourself?
Hi, Afshin. Thanks for invitation. Yeah, my name is Amin Abbasi. I am a business developer indeed at imec, and I will be happy to be here and answer some of the burning questions that you might have.
Oh, thank you so much for joining me. It's been a while since we met last time. It was like a few years ago. So thank you so much. So before jumping on your current role at imec as a business development manager, so could you please tell us more about your background in photonics and in semiconductor industry? So starting from your master's program and then PhD postdoc, and before imec, I noticed that you had a different role. I mean,
Yeah, yeah,
transitioning from academia to industry. Could you please just walk us through your journey?
sure, sure. Yeah, I started with physics. Physics was my passion, and I always says that my uncle influenced me because he was also studying physics and he was talking about this. If you go with the speed of light, time will stretch. They will be different. So that was kind of motivation. Then during master, I moved more specifically to photonic. uh, we had less access to the experimental setup, so I started with the more simulation, software, theoretical study. I remember when it was maybe 15 years ago or more. We were working on the generation of soliton in the VCSEL. So we had the dynamic model of the VCSEL. You know, it is laser is quite a nonlinear system. So we were trying to do this Maxwell equation using Fortran language to find the bistable state in this nonlinear environment and generate the solitons that they can also move. At that time, I didn't know what could be the application. Apparently, there are some application for the broadening, for example, or even for communication. But it was more theoretical work, introducing me to photonic world, and uh, I think that was the good starting point. Then we did some work also on the photonic crystal that time for all optical switching. So we wanted to do some Liz and nor and type of logic using integrated photonic. It was also theoretical. Then there was the opportunity to do the PhD in Ghent University in Belgium. 2012, I joined Ghent University photonic team, and I started work on the heterogeneous integration of 3.5 material with silicon photonic.
Mm-hmm.
You know, Intel has a similar approach. They put the 3.5 materials in direct bond with the silicon photonic, and they make a laser using hybrid approach. So we were doing similar things. For me, more specifically, topic was more related to directly modulating laser. So we were fabricating DFB laser in our clean room, and we were receiving the wafers from imec, and it was a nice moment. I remember a lot of fun stuff from those days. I got best student paper from the laser conference for the 56 gigabit per second directly modulated DFB laser on silicon. And then during postdoc, we tried to extend this activity to electroabsorption modulator and also detector. We had also some work related to that you can have a DFB laser, but if you isolate P contact, you can have a on both sides of the laser still electroabsorption modulator or detector. So it was a full transceiver we managed to reach to more than 100 gigabit per second. So it was academic time, fun, um, and I learned a lot on the processing side, on the working together with the team. We were doing design, characterization, and fabrication ourselves. So I
Excellent.
was lucky. I was lucky to be there in that team.
Yeah, I can relate to that because I'm coming from the same background in photonics and solid state physics and optics. I totally understand. It's a very, very fascinating field. Basically, I've always enjoyed doing photonics and physics and optics and research in that area. But yeah, thank you so much. You made my uh, life easier because I wanted to ask you about your accomplishments and you briefly touched on that. Thank you so much. So when transitioning from academia to your first industry role, so what specific challenges did you encounter, or did you encounter any challenges at all?
Yes, I think uh, I was somehow lucky because I joined the satellite company, OHB, German satellite manufacturing company, and we were doing more optical related topics project there. And normally these type of satellite company are very close to the academia, so they are doing R&D work. Normally it is the one of kind project or product. You send one to Mars and you need to build another one to do the moon experiment. So it was so the transition, it was not hard from the technical point of view. It was more like an extension of what I was doing in university, but there was some non-technical part. For example, qualification. That terms, I got to know that very hard during when I was in that company. For space, qualification is the must. For example, we had a 10 page or 20 pages of technical document for the project review, and we had a 100-page qualification document attached to that. So basically, any screws that goes there need to have a certain qualification. It need to have a document attached to that. If a PCB you have special substrate, is it radiation hard? Is not vacuum, thermal cycle, all these things. So it was a quite difference between what we were doing in the university and what we were doing. Another one was more like in university you try to do innovation that doesn't exist. The project, you want to push the limits, but in industry, I got to know that you you work with what is already done as a proof of concept. You need to improve the yield, for example. You need to improve the quality. You need to reduce the sensitivity to environment. For in university, if it was you put the laser on 20-degree, stay there, it is working. You put it at 25-degree, maybe it's not working. So it's not a big problem because you are doing proof of concept. But in a company, it need to work for some extreme case minus 40 to 80-degree. Doesn't matter what's happening, it should work. Maybe with the 3 dB change. So those were quite new and sometimes challenging to overcome. But you need to change your mindset basically to be ready for those.
No, thank you. And I noticed that so even during your studies, when you were in academia, you had partnerships with industry already. So I assume that it paved the way, kind of,
Yeah.
transitioning from academia to industry. Is that right? You want to elaborate on that a little bit?
Yes, I think it make a big difference if you get to know or you work on the industrial project within a university. So sometimes you are working really on the fundamental. For example, I don't know these particles. So, but if you are working for my case and the modulated directly modulated laser, that need to work, and some companies are paying to get the result, even if it is the proof of concept. So you go to the milestone based review meetings. You got to know the requirement. Still, You are free to do the different approach, but you have a specification from the beginning. So normally they are coming from the system specification. They said that I want to use this in the system, and this is the power that I need. So you got to know that there are well-defined structure specification. You need to aim for those. So it made you already start to do see this transition that you need to be prepared. They are waiting for the result. There is a soft deadline, hard deadline that you shouldn't miss. Uh, so it's not only about the paper. Uh, you need to have a result. Even if you fail, it is the result. But
Hmm.
you need to fail fast or win fast because time is important. If you fail, it is the learning that this approach is the dead end. So you switch. But yeah, you are prepared. When you are in the industrial project, you are prepared for the industry.
Excellent. I always tell people about this like fast failure concept that when you do an experiment and a very quick to test few like novel things that you have never tested before or no one else has tested before. So when you fail fast, so it's like a very good uh, tool in terms of learning as you accurately mentioned. So so that so what you already said is more about the project management and product development perspectives in photonics and in your previous roles. But let's move on to your team leadership
Yeah.
experience. So when you transitioned from academia to industry, so your one of your roles was a team lead. So what experience did you gain from that role, managing
Yeah.
people, and maybe from industry and academia? So.
Yeah. Again, when you are in the PhD, you are the one person army. You have your promoter that says that what is the right direction, but you make a choice, you decide, and you work in a team, but you are not responsible for somebody else. You are responsible for your own project. But when you are the team lead, it is a different responsibility. So uh, I got to know that people are different and you need to respect that. If you want to work with them, you need to respect that. And I think you need to have a bit of psychology uh, skills. Otherwise, it doesn't work. So it's not like you go with the pre-assumption that everybody think like you, everybody behave like you, and then yeah, this is the way you put the task, and you say that okay, next week I need it, and even the way that you say it make a difference. So some people want more friendship type of behavior, some people are more need a comment, and some people are proactive. You show the trace of what need to be done, and 2 months later they disappear and come back with all the results. Some people need the everyday basically follow up. So I think that was the learning for myself, that you need to respect the people and you need to understand them. But another point is that you need to be more programmatic. Uh, so you need to have a plan, take a note, follow the notes. The first item, next follow up meeting, go from the back basically. Let's review the actions.
Mhm.
So what we action last week, what action we defined. Let's start with that as a starting point of this meeting. So if you take a note, if you have a plan, and say that before meeting you set up a agenda. Yeah, these are the objective. 3 bullet point, not more. Two, we want to reach these objective, and these are the question mark. And you don't need to put the 2 hours meeting, so you can go with the 10 minute, 15 minute. So there were some learning period that and normally you don't have a time to learn from the other colleagues, so you are jumping in the water and they say swim. So uh, but it was fun. I think it was there were some sinusoidal up and down, but it was always upward
Excellent, thank you.
experience.
So basically, you're referring to the interpersonal skills and soft skills that one,
Yeah,
needs to practice as a team lead, for example, or
yeah.
a project manager or product development manager, which is absolutely important. And thank you so much. So let's not talk about your current role at imec as business development manager, because you have moved from that pure and technical background to a more like a business role. So, can you tell us about your roles and responsibilities as a business senior business development manager at imec?
Yes. Maybe before that, I want to elaborate that what happened that I was interested in the business role, because I had a fun in the technical role, and then, but the point of my previous company was that I was more like a early uh, phase of the hiring for the photonic. So I was dragged to different meetings with the customer, with also the partners, and I got to learn. As at that time, I was not that senior, but since there were lots of RF people or electronic, but they were limited photonic people. So I got to know the customer, how they interact with the customer, and also you need to have a bit of talent and skills, uh, or let's say personality for the business role. You need to be open to discuss with the people. You need to be open to hear the different people opinion, and this personality together with this experience somehow pushed for that role. And I saw that it is the business role at imec that I used to work before also when I was in university, and it is about the photonic. So somehow all the dots aligned together, and I got the position. Again, there was another learning cycle. uh, you get some basic trainings, so negotiation skills. uh, this is our system way of working. Every company has their own way of working. There are different models, and then you start to swim. There is a very steep uh, learning cycle. They don't wait for you in the industry, so you need to catch up fast. Otherwise, you will suffer because the expectation is that within a few months you are on your own, and of course, they are there to help, but that is the expectation that you are up there. So I started, and the main role for the business in general and for imec is to first of all have a strong technical background. Uh, compare maybe with other companies that they have a, for example, couple of products, and it is more sale rather than business development. So here, uh, every offer can be different compared to the customer request. So you need to be able to understand and speak the customer language, and also you need to understand what is your company's capability, because you don't want to just for every single meeting uh, go with your technical and start to filter the customer. Could imec be helpful or not? So having a strong background in the field, it helps to filter the customer, and then said, okay, here we can help, here we cannot help, and you go for the efficiency. And then there are some skills about the, I would say, operational skills. Uh, you learn those kind of things. It is the how system works. There are different models, but I would say they are operational part for business, always paperwork part, contract part, IP, legal, and also there is a these social part of it. You interact with the customer, you go to the conferences, you make a connection, you visit your existing customer, you discuss with them, and always you need to. I think for me, the trick is that you make sure that uh, you come from the human being perspective. At the end, we are all human. We are all living in this planet. So we don't want to just annoy each other. We want to help each other. We need to work together. It's not the customer partner relationship. At the
Mhm.
first, we are human. Let's understand each other. You build the trust, and then it comes after few months, sometimes few years. But you need to be patient, and if you gain that trust, it helps, and yeah, business grows. At the ultimate goal for the company, that business grow, and for the partner, your customer, you want to add the value. But there are some skills that you need to have, or you need to learn, to make sure that you are a successful business person.
Fantastic. Thank you so much. It's excellent. Yeah, I see that, your technical background has helped a lot with your current role because you understand the technology, you understand the nuances, as you said. So when dealing with, customers, you understand their technology very, very deeply because it's all like deep tech, right? So you need to have some sort of like technical background, which you do, of course. And then your passion and drive for uh, commercializing deep tech products. In your
Yeah.
case, photonics and silicon photonics and semiconductor chips and things like that. Go
And
ahead.
one thing is that you shouldn't be satisfied, or you shouldn't reach to the plateau. So
Mhm.
you say that I am a tech now business person. I don't care about what is happening in the market, innovation or trend. I think you need to be updated quite well with the trend. For example, on the photonic domain, just yesterday we saw the announcement of NVIDIA that they are working with TSMC. Jason showed this amazing silicon photonic based uh, device that goes to multiple terabits interconnection. Uh, he even said that ring resonator. So those words resonate with me. Um, 200 gigabit per second ring resonator, silicon photonic based laser or external laser. So if you are not updated, what is going on, you will not be able to help your, first of all, your customer, and also you will not be able to give these intelligence to your internal team, that guys, for example, now this is happening, we need to push, for example, modulator, we need to invest on the modulator because customer asking for that, or detectors, it is not about the speed, now it is about the sensitivity. So if you are in front side, and you need to understand what is the trend, what is going on, and about also your competitors. So if you want to sell something, if your offer is not uh, comparable with your competitors in the price quality, basically you are shooting on blind and just waiting for one stick. So I think it's not a good strategy. So you need to be updated, you need to go to the conference, you need to read the paper, and it's like a technical person, but it comes on top extra.
Mhm. No, that's a fantastic point. Thank you so much for elaborating on that. So let me, before moving to the next question, maybe let me ask you this question because like we discussed, you transitioned from technical background to a more sales and business background. But during that journey, so you touched on the learning period that you had. So for someone like yourself, or people like yourself who come from academia, pure technical background to a more business and sales background, it could be not just silicon photonics or what you do, but could be different industries, right? Could be anything. So during that learning period, what did you do exactly? Did you take, for example, online courses? What
Yeah.
did you like study something? So what did you do exactly to uh, gain the right skills for your current role?
Yeah.
Yeah.
Uh, yeah, for example, in the business role or in the technical, people are working with the abbreviation, right? We say DFB laser. So if you are not, you don't know what DFB means or DBR means, SOA means, you are already lost from the beginning. Your customer starts say these abbreviation. Your technical team are in the internal meeting, and so it is the same for the business. They are abbreviation, they are terms, IP terms, legal terms, business term, negotiation. So I think at least you need to have a basic background, or you need to study yourself. There are online courses also for that. I think that is the starting point, to have a basic understanding of these abbreviation term and condition. But then normally your company or yourself need to be prepared. You need to have these courses. Yeah, for example, for their negotiation course, for example, there are courses about the how systematically approaching to the customer intake. I don't want to name different methods that we had, but they are a well-defined approach for customer intake process. Customer comes, you have a different template to fill, or you ask the right question. So there are these things that you can learn. It is not about the talent, your background, but there are skills that you need to learn. So the courses are helpful. I remember before joining, I was also watching YouTubes about the business. There are lots of things online you can find, but to make it more professional, I think these specific business courses that either your current employee pays or you need to pay yourself uh, are important.
Mhm. Excellent.
Communication skills, negotiation skills. Uh, for business role, you need to have also financial background, because you are also going to uh, work internally on with the strategic team. If you want to invest on something where you reach to the break point, so break even point. So those financial terms also are helpful to have some idea.
Okay, fantastic. Thank you so much. So the reason I asked that question is that because there are a lot of, graduates, especially like PhDs that are looking for a job, and sometimes they cannot find positions in industry because of that. So thank you very much for elaborating on that because, so people who will listen to this podcast can gain some like insights into what they would need to develop like aside from their technical background to transition to an industrial role. Thank you
Yeah,
so
I
much.
think
Yep.
maybe on that, they used to be a traditional way to do that. You either you come from MBA side and
Mhm,
you take a course on the science, or you start from science and go for MBA. But
mhm.
right now you don't have a time, and everything is happening fast. So I think online, YouTube, online papers, there are lots of stuff that you can learn without taking 2 years of course, MBA course, for example, on the business. So for me, it was like a how they say organic grow. So I was a business. I moved to industry. I moved to business. So I didn't had any degree basically in this transition. So I think right now you need to be more proactive and learn it yourself
And you need to learn fast, very fast,
fast.
as you mentioned, very very accurately. So yeah, everything is like moving very fast, especially in deep tech and things like that. So it's even faster than some other traditional technologies and industries. So let's go back to imec's offerings, basically. So decades ago, as we know, so imec started as a non-for-profit organization, as a pure R&D organization,
Yeah,
and then started to become a business after a few years. So after the funding uh, that uh, government provided, then
yeah,
started to
yeah,
make money by itself. So we know that. So imec provides some offerings like in expertise in nanoelectronics, for example, in research. So you have fantastic clean room facilities, right, and labs. Then so some other offerings are the design and foundry
yeah,
services, something like that. And more importantly, so these like pilot systems. So imec helps with some startup companies
Yeah,
to, when they have a technology in semiconductors and photonics, to have uh, have the chance and opportunity to build their pilot system,
yeah,
because we know that. So when this type of research starts in a university, so the facilities you have, it is the in university level. So things like this, like
yeah,
semiconductors chips or photonics, they require like tremendous amount of resources and
yeah.
funding as well. So could you please tell us
Infrastructures.
more about the the benefits that imec provides to these startups, and what they typically gain from having this collaboration with you guys at imec?
Yeah, I think maybe always for me starting point to introduce IMEC, I always relate to that. So one extreme side is the university, right? You do innovation, you do die level stuff, and you want to do proof of concept. It is working. Now you have a brilliant idea, and you have a also pain point in the society. You want to address that one. So basically, market is there, and you got the funding also from the private investors. Then you cannot go to TSMC, Global Foundry, Intel, and say that I have an idea and I will be busy 3 years, for example, doing some experiment in a couple of wafers here, and they will I will do another experiment here, but I have a thousand of wafers volume in 4 years, 5 years. This doesn't work basically. So for them, from day one, you need to start with the volume. You need to have a business plan. You need to have a customer that is paying for that. So for us is we are uh, building the bridge between these two extreme sides. There is a CMOS foundries with the extreme volume. Some of them they are running 50,000 wafer per month.
Mhm.
These are the 200 millimeter or 300 millimeter big wafers,
Yeah,
and
big
that is the
stuff.
volume we are talking about. Typical volume in the CMOS fab. And on the extreme side, university, you have a die level proof of concept. So IMEC try to bridge this gap, and we say that we are the non-profit organization R&D CMOS fab with the capability for the pilot line. So it means that you have a concept. So we can start with the flexibility that we have. We can start from the wafer scale process development. We have for some application and technology, we have even design expert in house, and then we can help these startups. It can be corporate, it can be big company, but in this specific case for the startups, we can help to do the same proof of concept on the wafer scale, and also some process development, extra functionality. For example, you want to add the modulator, you want to add a detectors laser on it, so you add the extra functionality, and you are busy with couple of years, couple of months, depending on the technology readiness level. And then we can do uh, early phase pilot line production prototyping, and for those that they stay in this low volume, uh, low production, we can offer this from IMEC side. But for some of them that they go with the hockey stick approach, that they reach to the volume of suddenly thousands of wafers, we do this tech transfer basically. So since everything that we at IMEC we are doing, it is CMOS compatible. These are the standard CMOS tools. So from day one, you use the CMOS fab tools that is compatible with all the big fabs that they are existing. So we can take care of this tech transfer, and then it can be in the CMOS fab from that day. So there is all the way from the proof of concept on a wafer scale, design expertise, doing prototyping, volume production, and if need to be done in different fab, we can do the transfer.
Excellent. Thank you. So I have a question, because at AdvaTech we help a lot of tech startup companies. Some of them are like deep tech technologies and tech startup companies. So one of the things is that sometimes founders get into a trap of like over engineering their products without paying enough attention to the market, because
yeah,
sometimes, you're developing a phenomenal product or prototype, and you are looking at the technical side of it. For example, if it's like more energy efficient, or it has like more
yeah,
features than existing products in the market, but it's not typically enough. It's not sufficient, because having like some like fancy features cannot automatically guarantee market success. So what's your perspective on that? So how do we keep the balance between like the engineering side, the product development side, and at the same time, keeping in mind that the business development and marketing is equally important for a company's success. So what's your experience on that?
uh, I can name a lot of examples that I was at imec, and I have seen startups that they have a brilliant ideas. So I think one, maybe you need to think about the different mitigation approach. I think one will be that from early stage you got uh, senior or experienced people in the industry as your board or as advisor consultant, because if you go with the couple of graduate students and you got the money, you got 10 million, you got 20 million, and then you go with the university mindset. So I want to do the best in the power consumption because the existing solution has a 5 milliwatt. I will do it 1 milliwatt, and I have a proof of concept that 1 milliwatt is working. Uh, but then how much it will cost you to do that? So you want to put 5 million, and it will, that 5 million will multiply by 5, 10 in 3 years now, or not, because investor give you money to multiply that in a couple of years. And then also, is the market ready for that adaptation or not? Some markets are quite conservative, some of them are very price sensitive, and some of them they don't want to change basically.
Mhm.
uh, they are happy. For example, agriculture. So you start to deal with the farmers that they are using some old technology, it is working for them, and if you have a solution it is better, it doesn't matter. Even if it is cheaper, it doesn't matter. For them it is the disruptive to just learn that. uh, if you are in the health market, you need to think about not only the marketing part, not only the performance, about the insurance also. For example, you have a solution at the end that most of the, yeah, there are some argument about that, but application that for consumer or for the case that need to be adopted, who will pay for that price? If it is 5,000 euro and the insurance is going to pay for that, is the best, you will be successful. But if you don't have agreement with the companies in advance, and you will not get support, it will be hard to sell these 5,000 unit to the consumer health market, even to the doctor. So there are different aspects of it, and I would suggest always that if you are going in the different new market, you get the uh, experience of the people that they have done it, or they are in the market for 10 years, 15 years, uh, as a consultant, as a advisory board, as a CEO, as a, yeah. So any help from the experienced people will help that you are not going in the wrong direction. I have seen companies that got tens of million, and after a few years they end up with the excellent solution that is in their lab and is not in the product. So
The history is full of like those
yeah,
cases actually in different, very very different industries. I totally agree, especially in like some deep tech technologies like quantum computing, for example, and there are like dozens of quantum computing
yeah,
companies, but so just God knows how many of them will be successful. Of course, it's a very challenging technology. It requires a lot of expertise, and a good talent pool as well, because it's really hard to find the right talent for technologies like quantum computing, as you know, for silicon
Yeah,
photonics stuff like that. So, and another interesting thing is that like over 40% of startups produce things that nobody will pay for. So
yeah,
it's very interesting. So that's why. So bringing it's a very very accurate point that you mentioned, that bringing on like advisors or consultants or people who can help you from early stages of your
yeah,
uh, operation is extremely important, and this is something that a lot of startups overlook. So they,
yeah.
they wait until their MVP is ready or the product is ready, and then they seek advice.
Too
Sometimes
late.
just too late. Exactly. Exactly. So thank you so much. It's a very, very interesting thing. So let's briefly touch upon the technologies that you guys are involved in. Like as we mentioned, so silicon photonics for quantum technologies like 5G, communication, sensing, life sciences, and stuff like that. So we would love to hear from you. So what technologies, so what applications these technologies have, and who the customers are, and what are your
Yeah, yeah,
like
yeah.
day-to-day interactions with those companies and technologies.
Yeah, imec traditionally started as a fab for semiconductor. So mainly our focus those days they were on the logic CMOS scaling. Still, it is the big part of imec is on the CMOS scaling. You know, our phone they have a 5 3 nanometer technology. We are working on the beyond those technology. So most likely, maybe 5 to 10 years ahead of technology. We are focusing on that with the advanced tools that we have from the partners. For example, ASML. We have a strong collaboration with ASML, but at the same time, you can use the same tools and technology for other applications. So let's say the main application is on the compute, memory, logics, scaling. Then a good example is photonic in our case. So you use the advanced litho, advanced deposition tools for different materials like silicon nitride, silicon photonic, germanium, aluminum oxide. So these are all CMOS compatible. That for the transistor they have different functionality. In photonic we are using for as a waveguide, as a photodetector. So but they are all the same. So that is the beauty of the semiconductors, that for you can reuse what is already built over 50 years 60 years for new application. Quantum that you mentioned is a good example. Health is another. Health used to be bulky refrigerator size. Sometimes when we go to the hospital, full room tools that does certain functionality. So why not use the semiconductor and scale down, reduce the cost, but at the same time improve the performance? We are doing a lot of activities on the health. For example, when you integrate uh, macrofluidic channels
Mhm,
together with the photonic, together with the CMOS, different hyperspectral. So you are adding these semiconductor building blocks together, and you reach to the certain functionality that uh, it used to be dream uh, or magic maybe 10 years ago, and now there are some public information. I don't know how much it's public, but there are some activities happening there via our customers. And the point for us is that we are not on the application side. We are trying to be more on the foundry side, that we are not competing with our own customers. So they come with their design, they come with their architecture, and we enable using our technology, we provide them solution, and they can add extra layers to that, like electronics, packaging, uh, for different application, and they make a full solution. So for us, being a provider of technology, make ourselves unique. Then you start to serve different company in the same field with the same technology. So then it is the sustainable business, and for the it is good also for the other customer in the same field or other field, that they don't bear the cost alone. They share the cost of the technology development.
Mhm.
Uh, and it is the same, for example, for more than 10 years, we are working on silicon photonic for communication. Now we have a customer in LiDAR domain that they are using the same silicon photonic at 1550. We have a life science company that you're using also same silicon photonic for life science application, laser integration. So that is the beauty of using imec as a foundry. So then you have a building blocks like a Lego blocks. Customer can play with that and make a useful function that you didn't think about that before. Now, yeah, it is possible with the semiconductor technology.
Yeah, excellent. Thank you so much. And IMEC sometimes provides funding to some of these startups, as we briefly mentioned. So what are the requirements for IMEC to, uh, to invest in a company, for example, a startup company? So do you have like
Yeah,
specific requirements, or it depends on just the company?
uh, yeah. Details can be discussed, but more on the high level, we have this venture of imec called imec expand that they help startups that they are using imec technology
Mhm.
and the different field different application. And the idea is that to reduce this barrier for the startups, we know that maybe in the early phases it is difficult to get the funding for proof of concept, or in different stages. They are challenged. We have seen it in the past years. So that was the whole idea of that, having this support, financial support next to imec to help the startups. uh, but the kind of precondition is that they need to use imec technology.
Okay, so it's not like they develop a new idea and they bring it to IMEC. They become a customer, not a, like
They
a,
become a customer
yeah, okay.
at any. They can start with us, or they have developed something but they need to use imec technology.
No.
Then they can our colleagues can decide what are the criterias, and if they are uh, within that short list to get. But there is a opportunity there, and we have seen this with the different companies in semiconductor world, that they have this venture arms to help. They are also in US and Europe. They are such a business model that helps the startups.
Hmm. It's fascinating. So the services that IMEC provides is extremely fascinating, as you mentioned. So it's very hard to, for example, approach giant semiconductor foundries. You go to them with a new idea, and they're not gonna just interrupt their current operations to test something for you. But it's very very fascinating that IMEX provides such an opportunity for smaller companies, which is so some of like so so I know we are going back and forth between business and the technology, but so some of the like equipment, pieces of equipment like lithography equipment, they cost like upwards of 200 to 300 million dollars. This is not
Sometimes 350,
what's that?
sometimes 350 million.
Oh, yeah, okay. So you see, so is this most companies cannot afford that. So but you don't have access to equipment, to clean room facilities and things like that, so
Yeah.
you cannot have any significant progress, right?
Yeah, we have, I think, a couple of billion euro investment in the current facilities, and via CHIP Act, we are getting another support in coming years, that we will build a new fab in headquarter in Belgium. It is 20-30 minute drive from Brussels airport, basically, and that is the exciting moment. I think that was these we had this. Corona crisis that happened, and then chip shortage.
Mhm.
Uh, there were different initiative in different continent, and for us in Europe also, it was important to secure uh, our position as a innovation hub. So
For
these
supply
extra
chain, right?
funding, yeah,
For supply
this
chain.
will help, yeah, to secure that supply chain indeed. Yeah.
So and that lithography, those lithography equipment. pieces come from basically ASML, right? Is that correct? Or
They are for us. They are yeah, different partnership with different tool supplier.
Mhm.
Basically, for imec, I always say that imec clean room is like a zoo of the tools, and these are the most advanced tools that even maybe you cannot find in the CMOS foundries, because these are alpha beta version of the tools that they are not existing outside. But there is a special agreement with these tool supplier that we work together to enable this innovation in the semiconductor world. So imec has a special position in the semiconductor world when it comes to the ecosystem collaboration.
No, that's absolutely amazing. Okay, thank you very much. So, is there anything that you want to talk about and I didn't ask?
No, I think I really appreciate your help in the especially the startups that they might have a difficult life uh, to from bringing idea to the product, and maybe having these type of conversation, it helps them, give them a guideline to just move forward. And yeah, I think I always say to startups that uh, it is high risk but high reward. So keep up working what you are doing, and don't be disappointed with the maybe smaller hiccups. You will see a lot of disappointment, I will say, but if you don't tackle those, you will not learn, and you will not see what is the taste of success.
Absolutely, and never give up, right?
Never
So
give.
it sounds like a cliche, but it's really not, basically. So because entrepreneurship is all about creating something new that can potentially change the world and make the world a better place for people, right? So it's not about like making money necessarily. So because money is is a byproduct of your passion and drive for creating something new.
Yeah, yeah, indeed. If you are passionate, if you are enjoying what you are doing, it doesn't matter if you are working in the coffee shop or you are working in the high tech company. You enjoy your life. For me also, apart from the technology, all this discussion, try to set a goal. At least for me, is that being happy and make other people happy. Don't annoy other people. And if anything that you are doing, it is in line with this goal, I think you will enjoy it, and you will not regret when you are 70, 80 years old and you are looking back. I could have done that. I could have done that. I could be with, more with my family. I could follow my passion for the startup. So, uh, yeah, you need to always enjoy the life.
Exactly, and potentially leave a legacy behind, right? When you are
Yeah,
80 or 90 years old, as you mentioned very, very accurately. Thank you very much, Amin. It was a very, very enjoyable conversation. I always enjoy having conversations with you. So
my pleasure.
we have like this casual conversation once a while, like in our like personal, friendship and things like
Yeah,
that. But thank you very much uh, for your insight about like entrepreneurship, technology, and it's like I said multiple times. So IMEX services and offerings are phenomenal, especially for deep tech, silicon photonics, and semiconductor technologies. It opens up a lot of opportunities for smaller companies who don't have access to the facilities and resources that you guys have at IMEC. Thank you very much, and hopefully we can have such sessions in the future and dive even deeper into silicon photonics technology and things that you guys offer at IMEC. Thank you very much.
sure. It was my pleasure, and enjoy life.
Thank you very much.